going to learn some MCQs which was asked in UPRVUNL AE 2014. Okay, I already uploaded some questions in the same question paper in the previous video. It's a second video. Okay, let's get started. The first question: a system with the transfer function 1 by 1 plus st when exceeded with the step input takes 10 seconds to reach 50% of the step height. What is the value of tau? Okay, so we have to find the input first. They give the transfer function, right? Okay, let's see the answer. First, transfer function is 1 by 1 plus st. Okay, then we have to find the input response, that is c of s equal to, they give is it's a step response. So take 1 by s is a input. Okay, then c of s is the output. Okay, then find the output response of the system. Then what the answer was, 1 minus e power minus t by tau. Okay, and what they given was the step input takes 10 seconds to reach 50% of the step height. Okay, so the output it will be equal to 50%, and what time it will achieve the output is 10 seconds. So substitute t for 10 seconds and the response, whole response, e power minus 10 by tau equal to 0.5. okay, it's not 0.5, the one is come here, so it comes to 0.5. okay, so then take log on both sides and we get the answer. Okay, the tau is always greater than 10 seconds. So option 3 is the right one. Okay, the next question: the characteristic equation of the feedback control system is given by s cube plus 5s squared plus k plus 6s plus k equal to 0. In the root locate diagram, what are the coordinates of the point in the S-plane where the asymptotes of the root locate for the large k meet? Okay, what they asked was where the asymptotes of the root locate for large k meet. Where the asymptotes meet is the centroid. Okay, then we have to find the centroid for this question. Okay, what's the formula of centroid is, then first write the characteristic equation from which we have to find g of s. Okay, then what is the open loop poles and open loop zeros. Okay, then centroid formula is always written for open loop poles and open loop zeros. Okay, then what is the formula of centroid? Sum of the poles minus sum of the zeros divided by number of poles minus number of zero. That there are 3 poles here and 1 zero there, so 3 minus 1 it's 2. Okay, then add sum of the all the poles and the zeros, then we get the answer of minus 2. Okay, then minus 2 comma 0 is the answer here. Okay, the next question: in a single phase voltage source inverter bridge inverter bridge inverter, the load current I naught equal to 200 sin omega t minus 45 degree milliamps. The DC supply voltage is 220 volt. What is the fundamental power drawn from the supply? Okay, it's a simple question. If we know the average voltage of VSI bridge rectifier means inverter means, it is very easy. Okay, what's the power? Let's see the answer. Power equal to V01 I01 cos pi. This means for the RMS voltage, RMS current. Okay, so you have to find the RMS voltage and RMS current. Okay, then substitute what they give us, the angle also they given in the current equation. Okay, then substitute all this, we get the answer. Okay, and what's the average voltage formula? 4 Vs by root 2 pi is the RMS voltage of single phase voltage source inverter. Okay, then for current formula is already 200 by root 3 only. Okay, we have to find the RMS value. So 200 by root 3, put together by root 3. Here 200 is the maximum value, so we have to find the RMS value means then divided by root 3. Then substitute all the values, V naught, I naught, and cos 45 degree is the lagging angle of current. So then we find the answer. What's the answer? 19.8 is the right answer. Okay, next question: a 250 volt DC shunt motor has RF field resistance equal to 120 ohm and RA equal to 0.5 ohm. The motor operates on no load with the full flux at a rated speed of 1000 rpm with the IA 5 amps. The motor drives a load torque of 100 nanometer. Neglecting the saturation and the armature reaction, the armature current of the motor will be. Okay, first let's write what they given: voltage, RF, RA and IA, and rated speed also they given, and torque also they given. Okay, what they asked was the armature current of the motor will be. Okay, just write what they are given. Okay, what they given was the IA means it's a no load current, so IA1 we take, it's a IA1. Okay, then what is the torque developed? Torque developed was 100 nanometer. The motor drives load torque, so it takes us tau 2. Okay, so we have to find the tau 1. Okay, then we equate tau 1 by tau 2 equal to Ia 1 by I2. Okay, how they write was tau equal to torque equal to pi into Ia. Okay, in shunt motor the flux is also constant, so we take the torque is already proportional to I, so we equate this, then we find Ia2, that is the armature current we want to know, right? So first find tau 1. Okay, so tau 1, how we find tau 1? Eia, that is T into tau into omega equal to E into Ia, then we find the tau 1. How? Or if the E, Ia, omega values are there, no, we have to find E value by, it's a motor, so E equal to V minus IRA, all the values are given, so find VIA, E value and put it here and find tau 1. Okay, then equate tau 1 by tau 2, we know tau 1, tau 2 and Ia1, then find Ia2. Okay, that's it. Okay, so what's the answer was 42.2. Okay, next one, what will be the effort on bandwidth? The Q of the single stage tuned amplifier is doubled. Okay, it's not a big deal, it's a very simple question. Bandwidth is proportional to what? Q, quality factor. In circuit itself, it was there. Okay, so in bandwidth is inversely proportional to Q. Okay, let's see the answer. Q equal to FR by bandwidth. So Q is inversely proportional to bandwidth. Okay, what they given was the single stage single tune amplifier is doubled. Q is doubled means the bandwidth will be half. It is inversely proportional. So the became half is the right answer. Okay. Next one. The number of unused state is 4-bit Johnson counter. Okay. First, what is Johnson counter? We know the output is given to the Q bar is given to the input of the D flip flop. Okay, if Q is given to the input of the D flip flop means it's a ring counter, so it's a 4-bit Johnson counter, twisted ring counter. Okay, let's see how many states in the 4-bit. Normally for the how many states in 4-bit counter, that is 2 power n. N is the number of bits. Okay, so it's a 4-bit counter, so 2 power n is 16. Total used states are 2n. Okay, so 2 into 4 is 8. Okay, total state is 16 and used state is 6. Then what is the unused state? 16 minus 8, it is 8. Okay, so answer here is 8. Okay, the next one. In order to build a 3-bit simultaneous analog to digital converter, what is the number of comparator circuits required? Okay, and ADC, analog to digital converter, number of comparator circuit required is 2 power n minus 1. N value is 3, so 2 power n is 2 power 3 equal to 8. 8 minus 1, 7 converters required. Okay, let's see some of the points here. Flash type ADC is fastest and flash type ADC requires no counter, and N-bit ADC, flash type ADC requires 2 power n minus 1 comparators. The conversion time is T clock. Okay, we already discussed the answer here, so answer is 7. Okay, the next one. A small concentration minority carriers is injected in a homogeneous semiconductor crystal at one point. An electric field of 10 volt per centimeter is applied across the crystal, and this moves the minority carriers a distance of 1 centimeter in 20 microseconds. The mobility of the minority carriers. The question seems like very high, very long, but the answer is very simple. Okay, what they asked was mobility. What is the formula of mobility? Okay, let's see. Mobility equal to Vd by E. What they given was, they given E, electric field. Okay, what is Vd? Drift velocity. Drift velocity means the voltage is applied to the crystal. This moves the minority carriers at a distance of 1 centimeter but 20 microseconds. This is called as drift velocity. 1 by 20 microseconds is the drift velocity. So 1 by 20 microseconds is the drift velocity. So then substitute the answer of drift velocity and E, then we get the mobility answer. Okay, what's the formula of mobility? We drift velocity by E. Okay, the next one, ampere second is the unit of it. Is a very simple question. What is ampere second? Ampere I equal to Q by T. Okay, Q equal to IT. So electric charge is the ampere second. Okay, I equal to Q by T. So coulombs per second, ampere second is coulomb, that is the unit of charge. Okay, the answer here was electric charge. Okay friends, that's all about today. If you have any doubt in this question, please write it in the comments below. Okay, I hope this video is useful for you. Okay, thank you so much.